Hello guys, this is the implementation in EES of our previous problem, 1429. It's a good practice to you go to your diagram window to copy your problem. So here we have the problem that we just solved, and if you go back to our question window, we're going to start by loading our preferences. We already have defined some, so you can read a little bit better. So first of all, we are gonna have a title here, so we know what we know. So we know what we are doing. So the first thing that we're gonna define are the three variables that the problem is giving us. So this will be the dry bulb temperature, which is 26 degrees, the wet bulb temperature, which is 21, and we also know that the pressure is the atmospheric pressure to be 100 kilopascal. If you are not sure of your system, you can always check here. SI, the degrees are in Celsius, the temperatures in Celsius, kilojoules per kilogram, kilopascal, and degrees. So for these properties, we first gonna find out the humidity ratio. We come to function info, thermophysical properties, and we have a property here called air H2A. So it's a mixture of air and temperature, air and humidity. And you can see that we need three arguments now. So let's start with humidity ratio. And the humidity ratio, we are going to have the temperature. If it doesn't have any other explanation, is the dry bulb temperature. We're going to have the wet bulb temperature, and the third one will be the temperature. This omega, we're just going to have the names that we gave to the variable, and this omega should give us the humidity ratio that we compute. If I check, I have four variables and four equations, so it should be solved. If I press F2 of this calculator, should give me the same result that I have. You can see that we have different numbers, slightly different because of the table property that EES might be using. So I come back to my equation window, and now I'm gonna add the second one, which was the dew point, another relative humidity. So I have another equation which is relative humidity. I again put it in function of temperature and wet bulb and the pressure. So I can just copy this part if I want to solve some time, save some time. And I will get the dew point, because this is also a variable that is implemented in EES. And every time I am putting in terms of the wet bulb, since is the value that I got from my inside chrometer. I will change this a little bit and we'll call this the T. So I will copy the same parameters that I have for make my life a little bit easier. And now I have enthalpy. And I will get enthalpy again in terms of the two variables that I already have defined. Copy the parameters, paste them, and finally the volume. You can see that all of this are implemented in EES. You can check that you can have any combination of the variables, of the psychometric variables. We're keeping in terms of temperature at 12 volt temperature. And again, copy this parameter. If I press F2, I'll have my results. And I can compare them with my previous we can see that the relative humidity is 64.3, 64.6, dew point 18.8, 18.76, enthalpy 61.5, enthalpy 61.2, and volume 0.8773, volume 0.8777. So you can see this is very close. We have another thing to do here now. I go back and I will make a quick substitution, and I will say that T1 is equal to TdB, and that omega 1 is equal to omega. And you already know that this will create an array. I press F2 and I go to my array. I have this array. Why do I want to do this? Because I can plot a property plot, and I can plot a psychometric chart. So I can plot it and then overlay my array table. I will add a legend item, the point, and I will create this symbol so we can get it. I will put it in red so it's visible. This is my point 1. Okay guys, this is the end of the first video that we have for psychometrics implementation with EES. Thank you.